HVAC stands for heating, ventilation, air conditioning. Another bunch of letters worth knowing is BTU, British Thermal Unit. It's a way of measuring heat energy, how much is produced by a furnace or how much is moved by an air conditioner. The higher the number, the more heat energy we're talking about. There are different ways to heat a house. Let's talk about furnaces first. The heart of the furnace is the heat exchanger or firebox. It's just what it sounds like, a metal box of sorts with the burner inside. There's some sort of igniter to light the burner. So, the thermostat on the wall calls for heat. Inside the furnace, the burners come on, the heat exchanger heats up, and the air flows past the heat exchanger. The heated air then goes out into the house. There are different types of furnaces: floor furnaces, wall furnaces, and different configurations of those furnaces, single wall or dual wall, which means the furnace could be on just one or both sides of an interior wall to help spread the heat throughout the house. Heat basically just radiates out from these furnaces. There are going to be hot and cold areas of the house because depending on the floor plan, the heat may not flow around evenly. There are gravity furnaces. You will find these in older houses that are primarily vertical in design, multiple stories with open stairways. The furnace sits in a concrete bowl of sorts in the basement or in the crawl space under the house. The heated air rises naturally through ducts to the uppermost floor. As the air cools, it falls naturally down stairwells or through holes in the floors covered with grates and back down to the furnace underneath the house. The gravity furnace heats the house from the top down. Then along came the forced air furnace. The air handler or blower is what forces the air in a forced air furnace. Adding a blower to the furnace meant two things. First, houses could be designed differently. The architect didn't have to rely on the fact that hot air rises. And second, the house heats more evenly because the blower forces the hot air to different rooms of the house. You'll find an upflow or downflow furnace in a closet. The path of the air is either up or down. You'll find a horizontal furnace in the attic or in the crawl space under the house. The air path moves through the furnace horizontally. A package unit combines the forced air furnace and air conditioning system in one container. You'll find a package unit right outside next to the house or up on the roof. Anyway, the blower forces the heated or cooled air into what's called a plenum, basically a box that the ducts are connected to. The ducts channel the air to different areas of the house. Inside the duct, there might be a damper. This is sort of a valve that you use to send more or less air to different parts of the house. You balance the airflow by opening and closing the dampers. Now, depending on the insulation, weather, window exposure, and any number of other factors, a house can heat and cool differently. So you may have the damper set one way for balanced heating and another way for balanced cooling. You reset the dampers with the changing seasons. Inside the rooms, the air comes out of the supply register. Here too, you can control how much or how little air comes into the room. Air flows through the house and then back to the system through the return air register. Sometimes the furnace and ducts are in the crawl space under the house and the supply registers are in the floor. Shine a flashlight down into the register to make sure there isn't any foreign matter down there. Those are air ducts, not wastebaskets. But you know, water could be used to heat the house instead of air. It's called a radiant heat or hydronic heating system. There's a boiler, and since water expands with heat, there's also an expansion tank off to the side. A pump circulates the heated water through a system of pipes embedded in the concrete slab. Hot water heats the concrete and heat radiates up into the house, radiant heat. Or the hot water could be piped through radiators or baseboard convectors in the homes where heat radiates out. A convector, by the way, is basically a length of pipe with fins projecting out. The fins increase the surface area so the heat is dispersed a little bit more readily. Valves control the flow of hot water to different parts of the house, just like dampers would control the flow of hot air. There's also electric radiant heat. Here, electric current flows through a wire loop sandwiched between layers of drywall in the ceiling. Each room has its own thermostat and wire loop. Heat radiates down into the house. This is important to understand. It doesn't heat the air in the room. The radiant heat system heats the objects in the room. Furniture, walls, people. They in turn heat the air in the room. So it can seem slow to respond to a call for heat. It's like being outside in the warm sun on a cool day. You feel the warmth from the sun, but the air around you is still cool. 3 things here. First, look to see if things hang from the ceiling. When the hook was installed, the loop may have been cut through and disabled the system. If the hook was later removed and patched over, the break can be difficult to find. Second, check the electric rates in the area to get some idea of what it would cost to heat the home. Third, check the insulation above the ceiling because heat rises and there can be a significant loss of heat without adequate insulation. There are also electric baseboard heaters, heaters with electric elements in them that are installed at the base of the walls in the various rooms. If you see one of these installed under a window, by the way, make sure the drapes don't hang down too close to the heater. Let's talk about air conditioning. A conventional Freon-based air conditioning system is pretty simple. Inside the house there's an evaporator coil and blower. Outside there's another coil, the condenser coil, and a fan inside some big box called the condenser. A pair of copper tubes called the line set connect the 2 coils, and a compressor pumps the refrigerant, Freon, around the loop. Okay, inside, Freon flows through the evaporator coil, that's the coil inside. Air blows past that coil and the Freon absorbs the heat from the air. The cooled air is then circulated through the house. The heated Freon is pumped outside to the condenser coil, where the fan blows the heat away from the Freon. If you hold your hand next to the condenser, you'll feel hot air, right? That's the heat, not the air, but the heat that used to be inside the house. The Freon carried the heat outside. Airflow is critical. The 2 coils, the evaporator coil and the condenser coil, look something like car radiators. They're basically tubes that go back and forth, and there are these blades called fins that are on the tubes. They help disperse the heat. If either or both coils get clogged with dirt or debris, or enough fins get bent over, then the air can't flow through the coil. The airflow is restricted, the system can't work as well as it should, and most importantly, something's going to fail, and it's an expensive repair. Outside, look at the condenser coil. If it's clogged with grass clippings, then it needs to be cleaned. And in the future, if you have a mower with side discharge, make sure you blow the clippings away from, not into, but away from the condenser coil when you mow the lawn. And adjust the lawn sprinklers so they don't hit the coil, which could corrode the tubes and also block the fins. And whatever house you buy, inside, check to see if there is an air filter in the furnace and that it is clean. Make sure you regularly change the air filter. It costs nothing compared to the repairs you'll need if you don't. A couple more things. Set out a glass of ice water on a hot summer day. What happens? Condensation forms on the glass. Same with air conditioners. Condensation forms on the evaporator coil. That's the coil inside the house. The condensation drips into a drain pan where it either simply runs off or, if needed, a pump sends it out to a suitable drain. Turn the AC on and let it run. If water leaks out from under the indoor coil, the condensate drain is probably plugged and the pan is overflowing. This happens when that air filter hasn't been changed. The coil gets clogged, dust and lint fall down into the pan, and the drain gets clogged. The drain needs to be cleared, sure, but more importantly, so does the coil. And a new filter needs to be put in so it doesn't happen again.
I've got a lot more great stuff for you at houseiq.information. If you like what you've seen so far, do me a favor and tap the subscribe button so you don't miss future videos. And click the link to watch some more great stuff right now.